Hey everybody! Today we are going to start Unit 4, Day 1. So this is a video that goes along with this lesson, and our new unit is about sequences and series. And we're going to look at today, how do the sequences relate to functions that we have already studied and looked at? Okay, so our main focus today is going to be arithmetic and geometric sequences. Also, I have posted in the Google Classroom the reference sheet. So where we use the formulas, you will be able to look at them on the reference sheet. So definitely check that out. Okay, before we begin, let's just think about a sequence that you might know, right? A sequence is just a set of numbers. And a lot of times when we look at sequences, there is a certain pattern to them. So maybe you're thinking of, oh, even numbers, right? That's a sequence. Is there a pattern to them? Odd numbers. Ooh, what about the sequence of perfect squares? Have we seen that before? And maybe you even know some other sequences that you've heard about, like the Fibonacci. Okay, so again, that's our deep dive into sequences, which just is a set of numbers. Okay, so let's take a look at, right? What is the sequence? Well, I already kind of said that. It's an ordered list of numbers. Okay, and if you look over to the right, that's one that I had mentioned, right? And as it says, the dot, 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 some sequences, right, don't have an ending. They go on forever, right? So that's what the dot, dot, dot goes to infinity means. Okay, so let's take a look at something that I think we're familiar with, right? My plumber charges a $40 initial fee plus $50 per hour work on a job, right? Where have we seen this before? Right? Well, I want you to take a moment and pause the video, and I want to see if you can write this equation, right? What type of function is this? Hint, hint, we did this in Unit 2. And then see if you can fill out the table of values. Okay? So I'll pause the video and give you a couple minutes to do that. Okay, let's see how you did. So I'm hoping you came up with, right, in our function notation, m of n, right, where m's the amount of money and n is the hours, right? And the order doesn't matter here, but if you do it in order of the question, 40 plus 50n, but 50n plus 40 is the same, right? And I'm hoping that that looked familiar to you. What type of function is this? I'm hoping you were thinking linear, right? So if you look at the table, right, for 1 hour, right? And again, you could put this in your graphing calculator and get the table, but it's pretty easy if you substitute 1 in for n and get 50 plus 40 is okay. So first hour, the plumber, right, I'm going to have to pay 90 bucks. All right, second hour, did you get 140, 240, 290? Okay, I apologize. I skipped a beat there. Okay, 190, 240, and 290. Sorry about that. Okay, so if I list this in a sequence, so here come my squiggle set brackets back to haunt me. Got to make those little squiggly brackets. I'm going to list the sequence of numbers, right? And since I only was doing this for 5 hours, it's, right, a complete sequence. It doesn't go on forever. And this example is an arithmetic sequence, right? So now we've hopefully made the first connection. Oh, so linear functions are what we call arithmetic sequences. Now think about that, right? How did we get to the next value of our sequence? In this case, hopefully you're thinking we added 50. Okay, so now I want you to go to the next slide, right? And again, pause the video and take a moment, right? Think of the unit that you're going to be getting a test on, right? Coming up, Unit 3. and read that example and see if you can do the same thing that you did on the previous page. Pause the video. Okay, let's see how you did. Hopefully you said, right, again in function notation, h of n, and hopefully you were thinking exponential function. Bump, 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 bump. Okay, so again, exponential function, y equals ab to the x. And then when filling out your table down here, again, you could put this in your y1 and just get the table, or you can substitute, right, and do it that way. So hopefully you got 800 as the height of this bouncing ball, right? And then it's 640, right? So notice what's happening here. This would be exponential what? If you said decay, whoop whoop for you, and you're paying attention to our last unit, right? And then to write it as a sequence, get your squiggle brackets on, a little set notation, and write this particular sequence of numbers. Okay, so now our connection is, this is what we call a geometric sequence. So exponential functions get us a geometric sequence. So in an arithmetic sequence, right, to get to the next member, right, or term in our set, we added 50. Okay? And again, if I had added a negative, that would be okay too, right? So, but adding, right, seemed to give us arithmetic. So if you think about this and you think about exponential functions, what is the operation? Hopefully you said multiplication, right? And obviously here we're multiplying by that 0.8, right? So that's why our numbers are getting smaller. Our value is less than 1. Okay, so now I want you to go to the next piece, right? The next slide. And this is where I want you to take a couple minutes and I want you to see if you can do a couple of things. One, see if this is an arithmetic or geometric sequence, right? Am I adding, right, either a positive or negative, or am I multiplying, right, by a number greater than 1 or less than 1? All right. And then can you get the missing term that they're asking for once you figure out what's going on with the sequence? Okay, so I want you to pause the video for a couple minutes and see how many of these you can get. Pause the video. Okay, so take a look and see how you did. So were you able to identify the ones that were arithmetic, right? We were adding a value to get to the next term. And again, adding a negative, right, is justifiable. And then were you able to get the geometric ones where we're multiplying, right? And notice that in examples 2 and 3, right, our sequence was getting rapidly bigger because we were multiplying by a number over 1. Whereas in example 7, obviously when you multiply, right, by 1/4, right, you're going to have that exponential decay, right? Your numbers are getting smaller. And of course, pay attention to signs like in number 8, right? If you multiply by a negative, right, every other term, right, is going to be negative. But then a negative times a negative, whoop, equals a positive. Okay, so hopefully now you've got a little bit of an understanding between the difference of arithmetic and geometric sequences. So now we're going to take a deep dive into the arithmetic sequence. Okay, so take a look, right? And when we talk about an arithmetic sequence, we talk about what we call the explicit equation. That's a fancy term, basically, for right here where it says formula for the nth term, right? And the good news for you guys, you're going to love this. You don't have to memorize it. It's on the reference sheet. So whoop, whoop, right? But you do have to know how to use it and what it means, right? So explicit equation, right? Again, I'm going to kind of use both of the terms, or formula to get the nth term. the idea is, right, if I were doing an arithmetic sequence and I had the first couple terms like this one here, I've got the first 4 terms. But suppose I wanted well, you can even see down here in example 4, the 37th term. I certainly wouldn't want to have to sit here with my calculator, right, and keep adding, right, whatever that common difference is, right? Whatever that number we're adding is called the common difference, right? So you figured out on the previous page some of the common differences, how much we were adding to get to the next term, right? You take a term, you add, and you get the next term. So again, that is called the common difference. And in our formula, that's our D. Okay. So again, if you kind of look at the formula, if I want the 37th term, what do I need to know? Well, I need to know the first term. That's your A sub 1. That stands for the first term. And then we'll subscript, right, will mean the next term. So A sub 2. And if I want the 37th, right, that's A sub 37. Okay, and then the N, right? What does the N stand for? Well, that would be what? Take a look at it. Do you see the N in 2 places? So if you go down to this number 4 where I'm trying to get the 37th term, which we'll do in a moment, right? If I'm trying to find the 37th term, oh, then that N, right, has to match, right? Variable, right? When we define a variable, it has to match. So N just means the term that I'm looking for. It's the number of terms. Okay, so if you look at that, you should be able to, right? All right, I've got everything figured out in the formula. Let's actually see again how we're going to use this. So in the first part, right, you see that I have to find the common difference, right? So to find the common difference, one of the easy ways, now obviously some of these are pretty easy, but if it gets a little more complicated, remember, right, that common difference, of course, you're saying, well, what do I add to 5 to get to 14? But again, if there were decimals there, that would be a little bit more difficult. So to find the common difference, you can always reverse that process, remember, and take a term like 14 and subtract the previous term. And that'll always get you the common difference, right? So this is D equals 9. Okay, so we're going to determine the formula for the nth term. So this is that explicit equation that I've been talking about, right? So again, you don't have to memorize it, but if we're determining it for the nth term, remember, okay, that we're not filling in the n, because the idea is I'll have a formula that I could fill in any term I want, okay? But I do need to fill in the other things in the formula. So the first term, well, our first term, right, is -4 plus, now I do, again, don't want to fill in my n this time because it would have to match. Like if I wanted the 20th term, then we would fill in a 20, right? And then times our 9. Okay, so now we have a formula, right? And now we can go on to the next 2 questions. Well, if you look at this question, determine the next 3 terms. Well, again, I'm not saying at this point you'd want to use your formula because you have 23, right? And you can all pick up your calculator and then add 9 again, and one more time. All right, so again, I wouldn't use the formula for that. But now look at question 4. Right? I don't want to sit here and have to go up to, because I'd lose count where the 37th term is. And right? Keep going +9 in my calculator. Well, I'd mess that up too, right? And then I'd have to start all over. And you'd hear, some not nice words probably coming out of my mouth at that point because I'd be frustrated. So again, here's where you want to use the formula for the nth term, the 37th term. So let's use our formula. Right, so I'm going to find the 37th term, right? And that's where I fill in the 37, right, -1 times 9. And now this is as easy as pick up your handy dandy calculator, right? and put all of that in just as you see it, and you should find the answer is 320. You see why I wouldn't want to keep going plus 9, plus 9, plus 9, right? That would be painful. Okay, if you look at the next section, remember when we did our warm up, right? These were some, I just pulled the arithmetic sequences here, and let's practice, right? What I want to practice is writing the explicit equation, right? So it's using that formula from the previous sheet. So if you want to go grab that, right? It was the first term plus n minus 1 times the common difference. Okay, so that's what I'm going to practice. So again, if I look here, the first term is 4. The common difference, well, we found that out, right? You can just go back to your first page, or again, these are easy enough to see that it's 3. All right, so the explicit equation, which again is just a fancy way for saying I can find any term in this sequence, right? Any number term would be the first term, which would be 4, right? Plus n minus 1, because you're not filling in the n when you're doing the explicit, right? Because I want to be able to fill in any term. Okay, look at the next one. First term is 3.5. Common difference was 2.5. So the explicit equation, right, is going to be 3.5 plus n minus 1 times the 2.5. Right, and then again, this one, all right, I do need the first term. So we had figured out the first term is negative 1.5. And this time our common difference was negative, right? So that's easy, right? Doesn't matter. And again, this formula is right here for you on the reference sheet. You will always get the reference sheet in class. Not going to ask you to memorize something you don't have to. Okay, so again, now let's just go through. We practice writing the explicit equation. Now I just want to go through, can we, look at some other types of questions. What might we have to do? What would be a task here? Okay, so this one says, write the equation of the arithmetic sequence where the first term is 10 and the common difference is 6. Okay, so notice this time they're giving me information to write that explicit equation, but I don't have the sequence sitting in front of me like I did above. All right, but again, right, it's a sub n equals the first term plus n minus 1 times the common difference, right? So that would be a sub n equals, it gave me the first term is 10, right? Plus n minus 1. Remember, we don't fill in the n when we're writing the explicit equation. And then the common difference is 6. That easy. I know you're saying this is pretty easy. What's the catch? Not a catch, really. Right? Okay, so look at the next one. Find the next 4 terms of the arithmetic sequence. All right, so again, I say that if you're given 3 and you're asked to find consecutive terms, right, all you need to do is figure out here, what is the common difference? So again, let's pretend it's not as easy, right, as it looks. Let's pick a term. I'm going to pick 43 and subtract the previous term. Okay, so now you see the common difference happens to be a negative 6. All right, and then list the next 4 terms. That would be 37, 31, 25, and 19. All right, so that is one where, again, I wouldn't use the formula. We use the formula where it's helpful. We don't want to use a formula where it's going to make life harder. This is find the common difference and get the next 4 in the sequence. Okay, so again, I'm going to continue with what are some of the different questions that they could ask me. This one says, find the 10th term. Now I've got 1, 2, 3, 4, 5. It wouldn't be horrible to find the common difference, right, and get the 10th term. But, it's still kind of a little annoying for me. You guys might be able to do it faster because, you're great texters and, you're young and your fingers work better. But, my nails are getting in the way. So I'm going to use the formula. That's what I'm saying. Okay, so to find the 10th term, right, I'm going to take the first term plus 10 minus 1 Now I do have to know the common difference, right? But we said pick any term. I'm going to pick 14, subtract the previous term, and you know the common difference is 4. So easy peasy. Then here's where you might want to use your calculator, right? To at least check your mental math. I know you could all do this right in your head, but 9 times 4 plus 2, check it out. Did you get 38? That would be the 10th term. Okay, hopefully, whoop, whoop. All right, let's look at the next one. So this one is write an equation for the nth term. The minute you see that we're writing it for the nth term, remember, we're going to leave the n. Okay, so again, it's the first term plus n minus 1. Oh, I need the common difference. So what could I do? Well, I could pick 17 and subtract 8. Common difference is 9. Now, this is the explicit equation, but I will say that when you see this on a standardized test, they're not going to most likely leave it in this form because there's some simplifying that you can do. So now that we've seen this enough, I wanted you to get used to the form, right? Let's see if we can simplify this. Because again, when we're using a formula, we want the most simple form, okay? A lot of times to make things faster, basically. So if I simplify this, hopefully you're seeing I can distribute the 9, right, and get 9n minus 9. And then combining like terms, this is really just 9n minus 1. Oh, okay. So if I had to find a lot of terms in this sequence, it might pay, right, to get the simplified version. Because then all I have to do is, boom, plug in the n, and I'm done. Okay? So that's where that might come in handy. Okay, take a look at the next example. Find the 26th term of the arithmetic sequence. Okay, so we're finding a of 26. For which we have the fourth term is 24 and the common difference is 6. So now you see where they've kind of, kicked it up a notch because they haven't given you the first term, right? And you need the first term when using, let's write it again, right? A sub n equals the first term plus n minus 1 times the common difference, right? They gave me the common difference, bada bing, bada boom, but they didn't hand me the first term. So if you think for a moment, well, if we're on the fourth term, could I subtract 6 until I get to the first term, right? So if I subtract 6, I get to the third. Subtract 6, get to the second, right? You get the idea. Yes, I can. But I want to practice that you can also use the formula because maybe next time they're not going to be so nice and give you the fourth term. They'll give you the 20th. And again, I wouldn't want to keep going minus 6 in my calculator to work back to the first term. So don't forget, we have a formula, right, where we can find the first term because a sub 1 is in the formula, right? So let's see how that would work, right? We're kind of working the formula backwards. So we have the fourth term. So that is our a sub n, right? We have 24. We're looking for the first term, right? But then again, remember what we have here, right? We have the fourth term, right? So 4 minus 1. And then they gave us the common difference, right? So if you really look at that, it's really very easy, right? You can also simplify that to 24 equals the first term plus 18, right? So now you can see, yeah, all right, if I subtract the 18 from 24, the first term is 6. All right, now I can use this, right, to do my job and find the 26th term. Okay, so that would be 6 plus 26 minus 1 times 6. And again, at this point, use your calculator so we don't make a mental math mistake and get 156. Okay, let's look at this example here. where we actually are going to find the arithmetic means, right? And they can ask you for, as many as they want. This particular example says, hey, I'm going to start you with 16 and 91, and I want the 4 terms between, right? That's what the means are. They're in the middle. So if I look at this, right, I kind of set up this little visual for you. 16 is the first term. I don't know the second. I don't know the third. I don't know the fourth. I don't know the fifth. But this is obviously the 6th term, right? If there's 4 in between. So if I think about this, right, how do I go about finding, right? It says first, right? There's a little hint here. Use the nth term formula to find the common difference. Then use the value of D to find the 4 arithmetic means. Okay? So again, to find the 4 means, let's just think about this. If I knew what the common difference was, right, this would be a no-brainer. I would just take it and add, right? But I don't know the common difference. So some of you may be thinking, okay, well, we could use the formula, okay? But you can also do it another way, right? Think about if you know, right, 16 to 91, right? And then think about how many times you would be adding that common difference, right? So I'm going to show you with the formula first, but I want you to think about that second way we talked about. So again, if I use the formula, right, I have an nth term. I have 91, right? I have the first term. That's the beauty, right? And 91, remember, was the 6th term, so my n is 6. And the variable that I'm trying to find, right, this whole problem clinches on, I need to know the common difference, right? So again, you can simply simplify this, right? It's a very easy algebra problem to solve, right? And you find out D is 15. Once we know the common difference, this is going to be a no-brainer, right? Because we can add to get the middle, the 4 middle terms, those arithmetic means. But if you were also thinking, right, you can do this another way, right? You just have to be careful when you do it this way. A lot of you, I'm sure, are probably saying, well, look, we can get 91 minus 16 is 75. But you have to be careful. You're not dividing by 6, right? Because you're dividing by how many common differences you are adding. So take a look at what I'm talking about there. Let me just grab a color here, right? We're talking about, oh, can't see that color too well. Take that back. I'm going to use purple. Okay, so we're talking about going once, twice, 3, 4, 5, right? 1, 2, 3, 4, 5. So then that's why I divide by 5 and can get 15. So you can do it that way as well if that way makes sense to you. Or you're going to have the formula, so you can use the formula, right? And once we have the formula, this is pretty much a no-brainer. Okay, so take a look, right? And did we get the second term, right? 16 plus 15 is 31. Keep adding 15, right? And then always do a checkaroo when you get to that last mean is 76 plus 15, 91. Check, it is. Okay, so that was a little exploration into the arithmetic sequence. Now let's take a look into the geometric sequence. And again, you're going to be delighted that the formula for the nth term, otherwise known as the explicit equation, is on the reference sheet, right? So you don't have to memorize it, right? So I shouldn't have to hear you complaining. No complaining. It's on the reference sheet, okay? Your job is to know how to use it. Okay, so remember we said geometric sequences model exponential equations. Do you see the exponential equation? Y equals AB to the X. Hopefully you do. I spy with your little eye, right? And let's talk about some of the symbols are the same, right? Or the variables. So A sub 1, that's the first term. Now, instead of having a common difference, remember we're multiplying, so we have what we call a common ratio, right? That is your R. And if you look at this geometric sequence here, right, you can see that, oh, how am I going from the first term to the second to the third to the fourth? I'm multiplying by 3. So that common ratio is 3, right? It's your multiplier, okay? And then we are raising, so what's going to be our exponent in our exponential? It's n minus 1. And remember, the n's have to match. So if I'm finding the fourth term, then that n would be 4. Okay, and that's pretty much how it works. All right, so if we take a look here, we are given this sequence here. Okay, I pause for a moment because I see that there must be a typo here because this is not an arithmetic sequence. So everybody fix that to geometric. And we can even verify that it's not arithmetic, right? Because 24 minus 16, right, is 8, and 36 minus 24 is 12. There's not a common difference, but there is going to be a common ratio. So the same way that I suggested we find the common difference, right, is we pick a term, right? And then this time, instead of subtract, we're going to divide by the previous term, right? And get 1.5. All right, now let me do that again just to show you. I could pick 36, divide by 24, and also get 1.5. Okay, so again, to find the common ratio, you're reversing multiplication, taking a term, dividing it by the previous term. Okay, so now I have my first term is 16. My R is 1.5. I can certainly now write that formula for the nth term using the formula right there on the top of the page. A sub n, which means I can find any term I want when I use this. 16 is the first term, common ratio, raised to the n minus 1. And make sure you're looking at the formula and you don't, think, oh, it was just raised to the n. If you're given the formula, take the 2 seconds and look on the reference sheet. Okay, so now it says determine the next 3 terms. Okay, so just like I said before, right? If I'm going to determine the next 3 terms, I obviously could use the formula, right? However, I'm going to be honest, I probably wouldn't because I know the common ratio, right, is the 1.5. So I could just start here and go, okay, well, what's 36 times 1.5, right? Just boom in my calculator, right? Times 1.5 times 1.5, right? So that's what I would probably do, right? Just to find the next 3 terms. But I probably wouldn't keep going, right, when they asked me to find the 12th one, because we all know, I just told you, not really good with that calculator, right? I'm going to make a mistake probably on the 11th term, and then I'm going to have to go all the way back. And again, it won't be polite things coming out of my mouth because I'll be frustrated. So here's where I want to use the formula that we just created, right? And we had to create it in the previous, right, question here, so we might as well use it. Right, so the 12th term, right, is going to be 16 times 1.5. That's my common ratio. Raised, and now again, you can write 12 minus 1, or you can just say, oh, okay, I'm going to waste my time, and that's just to the 11th power. All right, and you can definitely see why I might want to use the formula when you put this in your calculator, right? Because it's a pretty big, long decimal number. Whoop, whoop. Okay, just like we did, right, with the arithmetic sequence, I want to get you so used to that formula, right, which again is on the reference sheet. Now remember, you do have to take the time and make sure, right, that if you're doing geometric sequences, right, which we are, that you're looking up the right sequence formula. right? Because if you're given the reference sheet, all right, you have to be able to look up the correct one. So it does matter, right? Am I doing an arithmetic or am I doing a geometric? Okay, so we're going to just, again, get that explicit equation so we get really used to working with this formula. All right, so we have the sequences that we grabbed from the warm-up, right? The first term is 2, right? And we already figured out the common ratios, but again, you could just do 8 divided by 4 is 2. Now, when we write the explicit, remember we're keeping the ends. There we go. Okay, let's look at the next one. The first term is 8. And again, if you forgot what the common ratio is, you can just do 18 divided by 12 or 12 divided by 8. It's 1.5. So using my formula, right, a sub n. So for any term I want, I would simply do 8 times the common ratio of 1.5, right, to that term minus 1. Okay, now again, it's not going to matter if I'm doing exponential increase, right, which models, or I'm doing an exponential decay. But what you hopefully do notice is that when you have, right, your sequence getting smaller, a decay, right, that your common ratio is going to be less than 1, right? I'm going to list it as a fraction, but if you wanted to do it as a decimal, I guess you can, because we did 1.5. You could do 0.25, but I'm just going to do a quarter because that's how I'm rolling, right? So 256, then I'm going to put the 1/4 to the n minus 1. But equivalent decimal is okay. All right, let's look. Can we do the last one? Let's see if you can do it. Did you say -4? Right, that's the first term. And notice this common ratio was the -1 because every other term is negative. Then a sub n equals -4. Common ratio is -2 raised to the n minus 1. Notice parentheses, if you're going to put these in your calculator, especially with a negative, is going to be very, very important. All right, so now what I'm going to do is the same thing I did with you with the arithmetic sequence. I'm just going to take you through some typical questions, right? And they're going to be very similar to the ones we did with the arithmetic sequence, okay? And so hopefully you'll get used to the question. But again, we're working with the geometric sequence formula this time. Okay, so here they're giving me, right, write the equation of the geometric sequence where the first term is 10 and the common ratio is 6. So again, I'm just going to use the formula. It says, remember it's exponential. So first term times the common ratio, right, which is, remember, is like your b, it's the rate, raised to the n minus 1. Okay, if I look at the next one, this is one where, again, I wouldn't waste my time coming up with the sequence formula because really to find the next 3 terms, all I have to do is figure out the common ratio, right? Take a moment, see if you can figure out the common ratio. Right? So you guys have a calculator, right? And you could have done 20 divided by 8. If I'm sitting here without a calculator, right, I'm going to pick 2 nicer numbers that I could just do in my head, right? Because the zeros are going to cancel out, and that's going to be 5/2. Or I'm sure a lot of you already got 2.5 because you put it in your calculator. So no big deal, right? Now, if I know the common ratio, all I have to do, right, is 8 times 2.5. No, not 8. Sorry about that. I want to start with the last term. Okay. 125 times 2.5. This is obviously a point where I should stop the video and obviously get more latte because I need more caffeine. Okay, but now I have, right, the 312.5, and then again, I would just use that times the common ratio to get my next term. That's a 781 and a quarter. And then again, 781 1/4 times 2.5 happens to be this number. Bada bing, bada boom. Right? So that one's easy. I'm not going to use a formula where I don't need to use a formula. Right? I'm going to use it where it's going to be helpful. Okay, speaking of being helpful, bada bing, bada boom. I now want to find the 10th term. Right? So again, if I only have 4 terms, I could figure out the common ratio, right, and do it the long way. But we already know I'm not that good with the calculator, so I'm going to use the formula, right? Because it's going to be really easy, right? I've got the first term, right? How long is it going to take me to do, 6 divided by 2, the common ratio is 3, right? So this is really easy. To find the 10th term, it's the first term times the common ratio. Now remember, this is to the n minus 1, so that's where I get my 9, right? And easy. 3 to the 9th power times 2. And you can put that in your calculator, use the parentheses. We get 393, sorry. We do get 39,366. And that's the 10th term. All right, so easy peasy, all right? The next one, I obviously have to use the formula because it says, write the equation for the nth term, right? I went a little crazy there with my underlining. Okay, so, yep, that's where I leave the n, right? There's the first term times the common ratio to the n minus 1. But I need the common ratio, which again, I can just do 12 divided by 3 is 4. Bada bing, bada boom. Now I've got my equation for the nth term. All right, this is flowing, right? You're feeling good? This is easy. Yes, I should hear cheering. Okay, so now I have to find, here we go, the 10th term again. All right, so this is one I would use my formula, especially since, I don't have that first term, right? But I do have the common ratio is 3. Now, again, this part would be up to you, right? If you're given the 4th term, it's not that difficult to go, right? Divide by 3, divide by 3, divide by 3, right? You can work your way backwards. But in order to help you practice using the formula, and what if they don't give you the 4th term? It's like the 20th. Then that would be annoying to get back to the first term. So we've got a formula, so we're going to use it, right? And again, I'm just looking this up on the reference sheet. Well, you're looking it up on the reference sheet. I kind of know it because I've used it so much. So then, right, now I'm going to use it to work my way back to find the first term. So I'm going to find first term, right? And that's easy because I have the 4th term. I have 108. I don't have the first term, but I have my common ratio. And then remember my n, right, is 4 minus 1, which, as I said, I would just make life easier and go, well, that's 3. Okay? And hopefully by now, y'all know what 3 cubed is. But if you didn't, right, you could put that in your calculator. We're going to divide both sides by 27 because that's good algebra 1. And we're going to find out that our first term is 4. Okay, now I've got first term common ratio, right? And I want to find the 10th term. Easy peasy. I'm going to use the formula, which says take the first term times the common ratio, right, to the n minus 1, so that would be 9. Pick up your calculator. 78,732. All right, whoop, whoop. Okay, this brings us to that last problem we did with arithmetic means. Well, now you can be asked to find, right, geometric means. And this one's just asking for 3 terms between 2 1/4 and 576. Okay, so again, there's going to be the two-pronged approach here, whereby, well, we have a formula, and you can certainly use that to find the common ratio. Because think about it. if I had the common ratio, right, I could multiply 2 1/4 by that, and then the next term by that, right? So it's all about finding, right, the common ratio for this problem, okay? But I do have everything else that I need if you want to use the formula. So if we want to use the formula, right, let's just remind ourselves that this is the formula for geometric sequence, right? I can do that because I have an nth term, right? I have 576. I have a first term, right? And I'm looking for the common ratio. And then what term is 576? Well, notice I've counted it out, right? So it's the fifth term, but that would be 5 minus 1, which is 4, right? And hopefully we've worked enough with exponentials that you would know, oh, we have to divide by 2 1/4 on both sides. Looking familiar, right? And we get 256, right, equals r to the fourth. Now, how would we solve here? Anybody thinking? Well, two ways. I could raise it to the quarter power, right? Or I could take the fourth root. Doesn't matter. Most students do like to take the fourth root. Now, here's the most important thing, right? And you'll see this a little later when we do the rational unit. But for right now, you're going to have to stay with me, right? Remember that if you're dealing with an even root, right, that although we normally take the primary root, if we're just saying, well, what's what's the fourth root of 256? It would be 4. But really, it could also be a negative 4. So here, when we're trying to find all the possibilities, you do have to consider when it's an even root that there will be a positive, right, and a negative. Okay, so there's find the common ratio, right? If you want to do this, again, the way that we talked about doing the arithmetic one, it's really very similar, right? You would do, right, in the other one, we took the last term minus the first term, but that was arithmetic. So if you wanted to do this here, you'd have to do the dividing. That would get you 256. Now, you'd have to know it's the fourth root because, again, we're going to count. We're going to do hops. That's 1, that's 2, that's 3, that's 4. So that's where, right, you could take the fourth root of 256, and you still have to know that it's a positive and a negative. Okay, now that I've got the common ratio, right, this is pretty simple, right? I just take, right, the first term. And remember, there's two possibilities. So the first term I could do, times, right? I can do multiply by 4, right, which gives me 9, right? And then again, I'm going to continue, right? Take 9 times 4 and get 36. 36 times 4 and get 144. So these would be one of my geometric means, right? The 9, the 36, the 144. But we said, you have to also use the negative. So if I took 2 1/4 times the negative 4, right, I would get negative 9. And if you think about this, right, the 36 would be positive and the 144 would be negative. So there's two possibilities, right, for the means, the positive and then ones with the negative. Okay, so you've got it now, hopefully, right? Well, at least you have the arithmetic, the geometric, and hopefully you're getting used to, I just look up the formula on my reference sheet. Easy peasy. So what I want you to do, okay, is pause the video and practice, right? Practice will make better. So you're going to have to determine, right? This is a mixed up practice, which is good, right? Is it arithmetic? Is it geometric, right? Is it a common ratio or a common difference? write the explicit formula, and then use the formula to find that nth term. All right, so now is really where I want you to pause the video. You can work together if you choose to work with a partner or on your own. It doesn't matter, whatever's going to be most helpful for you. But really take the time now, practice, see if you can do this, right? And then when you're done, right, when you've gotten your answers, right, play the video and we'll see how well you did. All right, you've got this. Ready, set, practice. Okay, here's the big reveal, guys. Take a look, right? Go right down and say, okay, did you pick geometric versus arithmetic? Because if you pick the wrong sequence, you're going to use the wrong formula, right? Was there a common difference or was there a common ratio? Then, can you find the common ratio or the common difference? Can you write the explicit formula? And you can see in number 3, I just reminded you that you can simplify it depending on, again, on the question. If they don't ask for it to be simplified, you can leave it, right? Like we have in the other examples. But if you're doing, like I said, a multiple choice question, they may have, right, 2n minus 12. So you would have to recognize, oh, well, why don't I see negative 10 plus n minus 1 times 2? Because they've simplified it, right? So that's just a reminder that it could be in a simplified form. And then can you use the formula correctly to get the given nth term? That's your last column. So take a moment and check and see how you did, right? And look at your work versus my work. And of course, I will also be posting the video for you for anyone who is absent can watch it, or if you just need to watch parts of it again to help you do your homework, right? Because everyone's going to do their homework. Yes. All right. If there's time, right, you can look at the last question. If there isn't, you know that it'll be in the video and it will also be posted in the notes key. So if you take a look at this example, right, what are some important things to look at? Well, it's an arithmetic sequence. So I've gone to my reference sheet and I'm pulling, right, it's the first term plus n minus 1 times the common difference. Now, what makes this problem, right, a little bit more challenging? Well, again, they're giving you the first term, but oh, look, it's an algebraic expression. They're giving you the common difference, but it's an algebraic expression. And they want you to determine the fifth term, right? So the process is the same. If you think about it, you're going to use the formula. But of course, there's going to be more what? Yes, algebra involved. So get your algebras on and give this a try because it's a really good one to try, right? Using your algebra skills, right? Pause the video and then check your answer. Okay, how'd you do with the final challenge? You can look at the work, right? If you got 11x plus 22, awesome job. If you didn't, then just look and see, right, if you made a mistake. All right, guys, I hope that helped you get through this lesson 1, and I will be back and see you soon. For now, this is Action Jackson signing out. Have a great day.